Okay, welcome back to the Dublin Academy Maths. Right, Mick is my name and we're doing the Leaving Cert Ordinary Maths Series 2, Episode 9, Functions, Paper 1. Okay, now we're coming up near the end. This is the last one, one of the last ones. I have one more to do and then, anyway, we'll try and wrap a few things up here. This is a question you have to do. Now, normally I don't go through the questions, but this one is kind of relevant. F of x is equal to this. Now notice it's not it's a type of cubic equation, so it's a curve, right? So from now on we'll refer to them as curves because it's much more handier. This explains a lot using the word curve. Now put in find f of minus 3. Well, you just do the same. You put minus 3 in for x and you get out the result. Same as input, output. This is the same as drawing a graph, pinpoint the points if you get the solutions. But down later you will be shown here, they're asking you for the values of x, find the coordinates of x, no, we'll continue on. Find the derivative fx of fx, right? Now the derivative, you know, follows a rule, okay, and that's the rule, remember that, embed that in your head, okay. Find the coordinates of the local maximum minimum. Now I'll get back to all this derivative things. Find the graph of the function, okay, so find the graph of the function and I'm going to put it in it lies between, right, minus 3, okay, x lies between minus 3 and 3. Okay, so x is greater than minus 3, less than 3. So you just put in the values here. Now you've already got minus 2, so you're only missing one other value, okay? Right. So you draw that graph, find the range of values of x for which the equation is equal to k. Now I'm going to get through this now. So this is the same equation, we're making it equal to k. And it has 3 real roots, that means it has 3 real solutions. Okay, now the derivative of something means you're finding the slope. That's all, you're finding the slope. Now I can't say any more, but I will get into it. The coordinates of the local maximum, local minimum points are when the slope is equal to 0. And when you find the slope is equal, you can put them in. Draw the graph of the function. Okay, you've done that. Find the range of values of k for which the equation is equal to k. Right, so in other words, equals to these solutions, which is equal to 0. Right, moving on. Right now. So we have a question here and it says f of x goes to, I'm going to use goes to, right, because it's much handier, it gets rid of all the confusion. 4x minus 18. Okay, so that all equals 0. Okay, because you can't have two equal signs in an equation. So this goes to that and it looks like a normal equation. It is, okay, a normal cubic equation, but anyway we'll call it a curve. It says find f of 1. Okay, so what do? I put 1 in for x. I've done this so many times. And this is the way I do my table. This is the way I would do my table, okay? So I would put in all my values, like the last was the range of between, x is the range, do you remember, less than 3. So I put in the rest of my values. But I'm asked these, f of 1, so I come out and I get a solution. I'm also asked to find f of 5, f of 1, you know, so I can go and do all these like this. But anyway, let's have a look at this. 1 cubed is 1, okay, because there's no minus here, no problems. Minus 9, plus 24, and minus 18. Okay, minus 18 and 9 is 27, 24, 25, so it's going to be equal to minus 2. Okay, now you can do this yourself, alright? And you do f of 5. Okay, so you put in a range of values and you get your range of values out and you get your solutions. Now the next question says find this. Okay, now it's not an inverse, not minus 1, it's a dash. That's the same as dy dx. Now you get very familiar with these because these are going to come up again and again, and not only in this question, they come up in the circle, the line, quadratic equations, and not so much quadratic equations. But anyway, it says find the derivative of that. Right now I know that's the solution to this. To find in the solution to this, I must use my formula. Okay? Now, what does that mean? Okay, so I multiply by the power. Okay, so I multiply by the power. So it's 3. See what I'm doing to fx? So this is the derivative of fx. I multiply the power and reduce the power by 1. 3 minus 1 is 2. Okay? Same again. 2 times 9 times x. Well, we can put it all in. Times x to the power of 2 minus 1 is 1. Do you understand? Okay, we'll do that again. So 2 times minus 9 is minus 18. Okay, so I'm going to put in 2 times 9, and x to the power of 2 minus 1 is 1, and anything to the power of 1 is itself. Okay? Plus, and there's a 1 here, 1 times 24 is 1 times 24, and x to the power of 1 minus 1 is 0. So getting the chance, anything to the power of 0 is 1. So 24 times 1 is 24. Do you see what I got? And see what I got here? And minus 18 is constant is 0. Okay, minus 0. It doesn't really matter because 0 is not involved. Will not get involved in this equation. So so you get rid of the x for the 24, and you just get your system, and you know your system, right? And that becomes minus 18x plus 24 is equal to 0, right? Now, the next part it says, now, is there something there that's very familiar that you can say, oh, I can see that 3 goes into all of these factors, so I can reduce my equation. Do you follow? I'm allowed to do that because you bring everything down to in the same ratio. So I divide across by 3. 3 6s are 18, 3 8s are 24. Okay? Now the next part it says find the coordinates of the local maximum and local minimum of the curve. Now the local maximum and local minimum of the curve, so we're looking at a curve, something, I don't know, something like this. So in this part and in this part here, we're not going higher and we're not going lower, and it's not getting any faster. It just has reached its maximum point. If you can imagine a person throwing up a stone, okay, it's a question, a normal question people ask, or questions in the paper, and then it comes down again. So the speed is increasing, and it has, you know, the distance has increased and the height has increased over time. So the distance over time will be same again. Distance over time, y over x. Get used to that. Speed is equal to distance over time. So I get this, and I get and I make it equal to 0 because at that point the slope is 0. Right? Now if it's a negative slope, it means it's going down. Okay? Well, not this direction, it's going down this way. In this direction it's going up. Reading from left to right. Okay? So you come along here and you see, well, that's going up, and you come along here and you know that's going down. Just imagine yourself walking. That's simple. Okay, that's simple. Imagine yourself walking. But anyway, it's the distance covered, right? Or the distance covered over the time covered. Distance over time. Speed is equal to distance over time. Just remember that. Okay? Now, so this is the maximum turning point because we can see it, we can visualize it, and this is the minimum turning point. Okay? And you will be able to know after a while how to differentiate between the minimum and the maximum turning points. But maximum turning points are related to functions, right? We have calculus also. This is parts of calculus. I didn't want to get into it, but it needs to be done because then it gives you a whole idea of what's happening, right? So so that's my so I'll go back to the equation, right? And I'll solve it. So I have to solve this equation because I have to find out where they're equal to 0. Okay? You know, I have to find out where. So I'll solve this equation. Now you should have already solved it. This is 6. What's the factors and factors of 8? I'm looking for the minus factors. So I'm looking for minus 2 by minus 8, or minus 2 by minus 4. What am I thinking? Right, so minus 2 by 4 is 8, minus by minus is a plus. Minus 1 by minus 8, that's not good. Which of those is going to add to give me minus 6? This one. Okay. Now at this stage, you know x by x minus 4, that quadratics and all those solving these quadratic solutions are in series 1 under algebra. Okay, plenty of questions there. Now, so these are my factors. So my roots are my solutions. Roots, x is equal to 2 or x is equal to 4. Now what does that mean? Okay, well it means that there, well this is graph is kind of gone, yeah, alright, so it's kind of, it's not touching the x-axis here on this turn. So this means that up here is going to be 2, well it's actually higher, 2, reading from 2, and so that's going to be 2, 0. Oh, it's not going to be 2, 0, we can find it out by putting them in. But anyway, you get the idea that you've got your values for x equal to 2 and x equal to 4. And I don't know which value it is. Okay, I don't know which one is my maximum, which one is my lower one, and I will tell you how to do that in the next calculus. I'm going to do calculus maybe next, or the line, the circle, the line. But anyway, you have now found the roots of where the x values is equal to the maximum and the minimum points. Okay, so it's either in x equal to 2 or 4. Now, if I want to find the other corresponding y values, I have to put them back into the original equation. Okay, original, very important. Okay, because I found my maximum, I found my values where the slope is equal to 0, and I found the x values. So now if I find the x values, I need to find the corresponding y values. And if I put in f of 2, which I might have done previous, it was asked previous, no. So if I put in 2 cubed minus 9 times 2 squared plus 24 times 2 minus 18, and I add them all out, okay? And it becomes, I'm not going to go through it all, but it comes 2 minus 2. The answer is plus 2. So then therefore I've got x equal to 2, 2 is the first one, so it's, well let's multiply that, minus 18. What answer did I get? 2. I got the answer 2. Okay, so that's 2. So in other words, there's one of the solutions. 2, 2. Okay, and then I put in f of the next coordinate, which is 4. And I put in 4. And I'm very careful watching my solutions. 4 cubed minus 9 times 4 squared. And I get out my result. Okay, and the answer in this happens to be minus 2. So that's the solution. 4 minus 2, right? Now you see what's happening here. So you're putting what you get for x back into the original equation. Always remember that. Back into the original equation. Right, so that's sorted there. Now I'll just bring this a bit higher. So I've got my, so I've got the point 2, 2 and 4 minus 2. Now I'm going to let you draw that out, and you can find them, you know, and you can sort it out. Now it asks you, the next part of the question, it says draw a graph, draw the function, draw graph, that's the way they will put it, or illustrate, of function f of x. They always remember to specify in the domain. Okay, this is telling you the domain of x. X lies between, it's less than 1 and it's less than or equal to 5. It's greater than or equal to 1, it's less than or equal to 5. So I put in my values again. I put in f of 1 and I go along the equation and I get out an answer, and this answer is minus 2. I put in f of 2 into my original equation. Okay, they're all gone in here. I can do the table form. If you want to do the table form, do the table form. So that's 1 minus 2, that's my first couple. Then of x2, and whatever answer I get out for 2, it happens to be 2 again. We did that before. Okay, and then we have 3, and I put in 3 and I get, so that's 3 and I get 0. Okay, so 0, that's a solution because y is equal to 0. So I put in f of 4 and I get out minus 2, so that's 4 minus 2. and I will go along and I collect this, and the last one is 5, and I put that into my formula up here in the cubic curve, and I get out 2 again, 5, 2. Right, so I can see one solution to this. Okay, so there should be 3 solutions. But it'll show you where the solutions land now. Yeah, there is. Okay, so now I get these points, right, and I put them into a graph, right, and that's the whole story here. So you get your points and you put them into the graph, or you plot the graph, and you end up with a function something like this. Yeah, something like that. Now you can see turning point, right? Next part of the question. Now, so you plot your graph, and there's no part to answer. Find the real values of x. Okay, so using your graph, find the solutions. They are the solutions. One of those solutions is 3. Okay, there's no other 0. I don't know why, but one of those is 3. That's for x is 3. So you have to from the graph you will be able to observe these. So these are obviously, these are not rounded solutions. They're obviously decimal solutions, and actually that's what they are, because I did look at them, and the values are yeah, one is at 1 and 4 point something. Okay, now so remember here, f, the derivative of x is equal to 0, and also here, because it's not going anywhere. Now where is it less than 0? Okay, where is f of x? I'm going to rub these out because we don't need them. Where is the questions we occur here? F of x, where is f of x less than, or greater than 0? Well, that's where it's greater than 0, because its slope, it's nothing to do, its slope is greater than 0. In other words, it's a positive slope. In other words, you're going up. Okay, where is f less than 0? And that's a negative slope, because less than 0 is a negative slope. Okay, and greater than 0 is a positive slope. So where are we going down here? Well, there's another slope here. If that's the way we work this out, there's another slope here. That's going down. Okay, and it's going, the slope is less than 0, and it's going all the way down here until it reaches equal to 0. Okay, because it's going down, it's a negative slope. You have to remember that. Even though these are very confusing here, how could the bottom here be equal to 0? Because you're at the bottom. You're not going up nor down. Okay, and it's the same at the top. They all have, how would you say, upper limits. They have troughs. Okay, so these are their troughs, and at those troughs there is equal to 0, the slope is equal to 0. So all these type of things you have to interpret. Okay, so where is the, you would use arrows, and you'd find the solutions where the graph crosses the x-axis. Okay, now there's another part to that question, but I'm going to leave that for the line because it's quite difficult. So that's everything, I hope, you know. So when you're, I'm just going to talk about a few things here. I'm just going to talk about, so if I was to draw a line here, you know, this line at some point crosses these axes, and I just want you to think about that. When it crosses there, y is equal to 0, and when it crosses here, x is equal to 0. So you know, you can find and you can plot a lot of things, but you know, this is you know, this has been used, you know, without getting too specific, this has been used for plotting velocity of an object in the stars, you know, or cars or anything like that. But they can actually predict its location through its curvature. So predicting its curvature, you can predict its velocity, how far it's going, how fast it's going. And there's all this involved, okay? And we'll get a bit more specific later on in calculus, and you'll be able to understand it completely better, okay? Because there are 2 types of functions here. There's a function probably related here, but probably related how much you eat in a certain time of day, you know, this could be calories, and this could be the time, okay? So you'd have your calories, and you find out at 3 o'clock I ate, 3 o'clock or 2 o'clock I had my dinner, and this is how much I ate, capacity or whatever. So this is just a normal graph. But when you get something like speed or rates of change, you have to change your thinking about what is happening. And it's not such a great, you know, phenomenal. It's quite easy to cop onto. But anyway, so I'm going to leave those questions with you, and the best of luck. Thank you.